Hello grade 12, welcome to my channel, and let us have a look at some more NBT related questions. This one was by request by one of my students, and I hope it will help the onlooker here to also strengthen their effort. So we have question 53 here. So we need to find the values of A and B such that the sigma of 2 to the r minus 1 from 5 to 18 is equal to the sigma of 2 to the exponent p from 1 to 18 minus the sigma of a half to the exponent minus p from a to b. So obviously the first thing that we need to accommodate here is simplification. And we are going to use BODMAS such that we apply this in reverse. Okay? Because here we do the so-called reverse operation or inverse operation. Because when we see brackets, that's division when we keep everything. So to undo it, we would then multiply out. Ordinals, this is some number raised to a particular exponent, and that means we can take the root depending on the order in which that power is. And then division and multiplication. If we have division, we multiply. If we've got multiplication, we divide. Addition and subtraction. If we're given addition, we do subtraction. If we're given subtraction, we do addition. So this is simply what happens here. So let's simplify here. So we've got sigma of 2 into 2 to the r times 2 to the minus 1. This must be equal to the sigma of 2 to the exponent p. This one is simple. Okay, so this is something we can write like this. So we are further simplifying. So we've got sigma of 2 into 2 to the exponent r divided by 2. If we write that as a positive exponent. So this is sigma okay. So we sort it out nicely. So this is going to be 2 to the exponent p, essentially. So what this reveals is that these two general terms are the same, essentially. And obviously, this 2 will cancel that 2. So our final simplified equation has sigma from r equals 5 of 2 to the exponent r up until 18 terms, or at least 18. So we've got here sigma of, starting from p equals 1, 2 to the exponent p minus that situation over there. So from here, guys, a student of maths should know that once we've got an ordinal like that, the base becomes the common ratio for a general term like that. Okay, so this needs to be clear. There mustn't be any flinching ongoing there. But I will just show you quickly how this can be arrived at the standard way. Okay guys, so essentially the standard approach is to expand to 3 terms at least and then work out the common ratio. So these ones are easy, but where there are variables, so we have to understand the fact that where we started from, we increased by 1. So we show that out and we simply use our exponential rules to work out our common ratio. So this means we need to evaluate our sums. Now to evaluate our sums, we will have here 2 to the 5 into 2. Essentially the number of terms is going to be 18 minus 5 plus 1, which is 14. That divided by 2 minus 1. It's equal to 2 to the 1 into 2. Now here we will have 18 terms. Okay? Minus 2 to the a into 2 to b minus a plus 1 minus 1 divided by 2 minus 1. Okay? So we keep moving. So we will appreciate that our denominators are effectively 1, so they can easily disappear. So all we have to do is to FOIL each expression in the numerator. So this gives us a 2. Now same basis, we simply add exponents. And then the same happens here, 2 to the 19 minus 2 minus 2 to the b minus a plus 1 minus times minus, it's a plus 2 to the a. So we can clearly appreciate that 2 to the exponent 19 is of the same order on either side of the equal sign. So these will cancel, as well as minus a plus a. But now we can make this the subject. So when we transpose it to this side, we will appreciate that we have 2 to the b plus 1 equals. We transpose this to this side. This is 32 minus 2, which is 30, plus 2 to the exponent a. We can make this equation 1. All right. So we've got a part. Tn equals a Rn minus 1. This is us going into this sequence or series because we've got a and b. So Tn here is basically our last term right there. So this is going to be 2 to the exponent b equals 2a times 2 into, now for n we substitute the b that we were going to use at the top there. Alright, we simplify further. We've got 2 to the exponent b equals 2 to the exponent a times 2 to the exponent b times 2 to the exponent minus 1. So we can see that we want to isolate 2 to the exponent a, and we can literally get rid of 2 to the exponent b. So we divide by all that we don't want, and we will see that this and that will cancel, this and that, they literally divide out and can be invisible. Perhaps that's the correct word to use. Alright, so let's go on, guys. We've got some work to do. So this implies that now we've got 2 to the a coming out alone equals, we change this to a positive exponent. That is what we have. Same basis, we equate the exponents. So a is equal to 1. This implies that equation 1 is going to be 2 to the b plus 1 is equal to 30 plus 2 to the exponent 1, which implies that 2 to the exponent b plus 1 is equal to 32, which implies that 2 to the b plus 1 is equal to 2 to the exponent 5. Same basis, we can equate the exponents. Therefore b is 4. So therefore our answer for this question becomes essentially B. Okay. Alright, so one can appreciate here this is one of those questions, okay, where multiple steps are involved, and of note, we needed to use simultaneous equations. Okay. So the concept of simultaneous equations needs to always be with us. Okay, so let's move on to the next question. So we've got question 54. So this is with respect to function f of x, which satisfies this particular equation. F of 1 minus x plus 2 times f of x equals 3x. Okay, so now we need to find f of 0. Okay, that's easy. So let's see if we look for this f of 0. So this means we will substitute. By the way, before we do this, we need to simplify this in a way that we can understand, because 1 minus x wouldn't make sense. But if we reverse this order, remember reverse operations is still at play here. Simplification. Why am I insisting on this simplification? Because minus x means if in the equation we substitute, or at least we multiply the x terms by negative, this becomes a horizontal reflection of the function f. And when we add 1 within that equation or in the notation, it simply says we are doing a translation to the left. So this is still function f, but horizontally reflected and then translated to the left by 1 unit. So let's see now, we have to find f of 0. F of 0, this means where we see x, we put 0. Okay, great. So what does this simplify to? This simplifies to f of 1 plus 2 times the f of 0 is equal to 0. And this simplifies to f of 1 is equal to minus 2 times the f of 0. Now this has introduced for us something, f of 1. Okay, because we still have the function f. So how about we look for f of 1 from the original? So this becomes our original, because this is the expression that would make mathematical sense in terms of functions. So let's see, where we see x, we put 1. Okay, so this implies that we will have, this simplifies to basically f of 0 plus 2 times f of 1, which gives us a 3. Now, seeing that from above, we found out that f of 1 is equal to minus 2 times f of 0. So this is going to be plus 2 into minus 2 times f of 0 is equal to 3. F of 0, this becomes minus 4 times the f of 0. and these are effectively like terms. Now 4f of 0 1f of 0 minus 4f of 0, it's minus 3 f of 0 is equal to 3. So we want to isolate f of 0, so we divide by minus 3, and what we do on the one side we must do on the other side. So basically here, okay, maybe let's write it here. Therefore, I don't want to write it here, man. Therefore, f of 0 is basically equals minus 1. Therefore, our answer to this question is what? Option B. Alright, so this is how a question of this nature could be sorted. Again, a very nice question, one that demands a little bit of thought because it is necessarily a higher grade question, as we can see. Alright guys, so this is fine. It answered the question and we are good. Let's move on to question 55. Oops, cannot move it up. I forgot. So we are given here, after the parabola y equals x squared minus 8. Alright, is shifted. Now we are familiar with the shift. It's a translation. It can be up, it can be down, it can be left, it can be right. But then it is rotated. Now we really don't understand so much about rotations, at least in grade 12. But there are some things that we can think of that perhaps we can just imagine doing a rotation whichever direction we choose in the Cartesian plane. But we don't have a bit of a, what can I say? We don't have something that crude that we can say we can apply to explain this, but we can just think of it and just go for it. Now we are told you that the original x-intercept have become these 2 points. Okay? But now if we inspect these 2 points, we'll see that A has 2 and 4, B has 4 and 2. So these are basically inverses. Okay? So this is key, that these 2 points are inverses of each other. And remember, these are the x-intercepts. So x-intercepts are equidistant from the axis of symmetry. Now, let's answer this question. Find the equation of the axis of symmetry of the transformed parabola. So obviously, if these 2 points are inverses, it means these 2 points are going to be symmetrical about the line y is equal to x. So this makes option C the answer. Okay. Option C is the answer. So again, just knowing what to do is very important, guys. Some questions can be answered at a go by just knowing what is going on, because at times the rotation is not so nice. But let's just try to use the Cartesian plane to explain this situation. At least for now, to try and make someone understand. Now a parabola like that, it's a smiling parabola, right? I'm not going to be explaining such concepts at the moment. This should be easy. So let's say this is our parabola. Okay, so we know that these 2 points which is the x-intercepts, are basically symmetrical about the axis of symmetry, which becomes the y-intercept. sorry, the origin, or at least the y-axis. Now we don't care because this is going to be minus 2 root 2 and positive 2 root 2, but that's not what we're interested in, and obviously this becomes minus 8. Okay, that becomes minus 8. Now what do we do? Well, we're going to try and figure out what happens when we rotate this. We shift it and rotate it. So now we can see here that we've got our graph. We can shift it up. Why? Do I know that this is probably a shift up? Because both these coordinates are positive. And then let's say we rotate this way, because this is the orientation this thing is giving us, and then perhaps we move it here. It doesn't really matter how we moved it. The fact of the matter is that it moved. So maybe let's rotate it a bit back. Okay, so this is what we see. All right, so probably this is what it looks like. We don't know. Probably this is what it looks like. We really have no idea. All we know is that this is such that the intercepts are as described. So maybe let's leave it here now and say, well, this is probably how our parabola looks after we rotated it and shifted it. So let's imagine now, here's our x-intercept here. So this x-intercept becomes point A, and let's say directly across that, over here, we've got this other x-intercept as B. Okay, so that's point B. Because we saw that the best rotation that we can think of is this one. But the same could apply, that we can rotate this graph the other way around, and then it's facing that way. It still would work. Okay, it definitely would still work. But now let's just choose one rotation and work with it. So what we noticed is that point A is an inverse of point B. So this would simply suggest that here we've got 4, and then right across this one we've got a 2. Remember, this is not drawn to scale. So that would be a 4, and then we would have a 2 there. So we understand that these are literally inverses. So it means these ones are symmetrical about the line y equals x. So this becomes our axis of symmetry. So graphically, we can appreciate this, essentially, because this becomes an inverse line. At least the guidance is the 2 coordinates, which were originally the x-intercepts. So I hope we understand this part. Okay, so obviously here, what we need to note is that A and B are inverses of each other. Okay, so therefore they are symmetrical. About y is equal to x. And to answer the question now, we can see that the answer to this question becomes option C. Okay guys, so this question is not quite a nicer one. It's a low-key higher grade because it can give a bit of a situation to the mind, but what matters is understanding functions very well. Okay, so this is essentially not so bad once one appreciates what needs to happen here. Obviously, like I said, this graph could easily be drawn looking like this. Okay, this could be that graph. Again, those points would still essentially look the same. So the rotation, the axis of rotation could be any, however we choose to do it. So this is essentially just suggesting that at the end of the day, these 2 points should remain symmetrical about that line y equals x. At least we understand that the rotation that this graph should take should be either this solid graph here or this dotted graph here, because any one of these two graphs answers the question. Okay, so I hope the student and everyone else who's looking here finds an understanding of why option C is the best answer. Okay, let's move on. Now we've got question 56 here. Question 56, we are given a line y equals 6x plus 3 and a line y equals mx. Okay, so this is the line that passes through the origin. We are told that they intersect below the line y equals minus 9. Now we need to find the values of m for which this is possible. So obviously, guys, what matters here is to draw the sketch. The sketch does not necessarily need to be accurate. It just has to send the message. Okay. This is what matters. So this is x. This is y. So obviously this is a positively sloped graph, so we can just do it, and it's fairly steep. Perhaps not as nice as I want. Okay, maybe let's leave it at that. So this is our graph for that function. So this is y equals 6x plus 3. Obviously, it means it will cut the y-axis at 3, and then it will cut the x-axis at minus a half. Okay, that's the story. But perhaps let's write it on the other side. Okay, that's the graph. So we can draw it quickly, and again, be flexible, guys. Know how to do this quickly. Now, we've got a line y equals, I forgot to write. We've got a line equals minus 9. Y equals minus 9. Now, let's say this graph is this one right here. Remember, the graph doesn't need to be to scale per se. So this is the line y equals minus 9. Okay, great. So we are saying this particular graph has to intersect this other one, where below this line, and yet this line passes through the origin. So it won't happen if this line is passing through the origin this way, because they literally intersect above this line. So this already says the orientation is this way. That's the orientation that this is dictating. Okay, let's just extend this a bit. Okay, so little by little I'm discovering things on this thingy. Yay, you have to be that color. You must be Kandaman. So basically this is the line y is equal to mx. So guys, we can appreciate that, okay, this is the position that this line has to take if these two are to meet below this particular line. But now we need to find the range of gradients that can satisfy this situation. Obviously, the first one to consider is when this line actually intersects this graph right at that point. Okay? So let's just do it. So, man, I'm happy. This thing is far more better than I thought. Okay. So, basically, okay, maybe let's shorten it a bit. So basically, this is one way that could limit this situation. Right. Obviously, we can see this graph is less steep than the 6x plus 3, which is what we want. But now we need to define this point. What would be this point? So if we substitute minus 9 here, so minus 9 equals 6x plus 3. We transpose, we get minus 12 equals 6x. Therefore, x is minus 2. So it means this point is minus 2 and minus 9. So it's important because at the origin, we've got 0 is to 0. Perhaps let's not even be silly here and write coordinates. Just noting this is the origin like that, it's more than enough. So guys, we can see that if this particular line was to be this line that passes through the origin and meets this other line right on top of this line y equals minus 9, this would be essentially the gradient. And any gradient less than that, it says they will meet above instead of meet below. Okay, so that's great. We can appreciate that. And essentially, we also know that the yellow line is the correct line. So this is what we want. It answers the question. But then, what are the limits? The other thing for us to consider, guys, is essentially a line that is parallel to that, isn't it? Because this could happen still. Find that this line runs parallel to our proposed line. So essentially, it could still pass through the origin, but run parallel. So this line is effectively parallel to our. So that would be also another limit, because we will see that if it is not parallel, therefore it's going to be slightly negatively sloped, or even still positively sloped but very steep. That means they will meet above this line instead of below. So our limit is a line parallel, meaning parallel lines have equal gradients, and this line. So the limits are here. So that is our set of constraints. So that means the line y equals mx must have a gradient that puts it in between this brown line and this blue line. Now the question is, what is the gradient of the blue line? Now the gradient of our blue line here is going to be y at the origin minus y at one other point. It's going to be minus 9. Then this is going to be 0 minus 2 and this gives us a 9 over 2, which is equal to 4,5. 4,5 is basically 4.5. Okay. But now what is this gradient here? The gradient here is a 6 because it's parallel to the other one. So therefore here, to answer the question, we know that m has to be less than the gradient of 6, but greater than the gradient of 4.5, since this is presented like that. So this means B is the answer. Okay, so guys, graphs need to be understood in terms of that this line passes through the origin, number one. Number two, we can see that the gradient of this line has to be between the blue line's gradient and the brown line's gradient. Why? Because this is effectively equal to that when passing through the origin, and this satisfies the constraint when that line is sloped between these two lines, at least to some extent. So the graphical method, guys, always works. So again, be quick and be analytical, because this is more like analytical geometry coupled with functions, algebra, and all that we already know and understand. I hope this is clear, guys. So let's move on. So we've got question 57. So let's quickly go through this one. So we're given here AB is the diameter of the circle, with AB equals 10 centimeters, and the area of triangle ABC is equal to 11 centimeters squared. Obviously, if that is the diameter, it subtends a right angle. Okay guys, let's finish up. So if this is a right angled triangle, so Pythagoras works and any other triangle rule. So it says here, find the perimeter. So the perimeter is basically all the sides added. Now we are given a hint here, because remember we cannot use calculators here. So let's do this expansion. So maybe let's draw the circle first. And it looks like this is what would be my diameter right here. And I've got that story there. So this is A, B, C, and I have a right angle there. Okay, not a problem. So what are we going to do here? So we are given that we need to expand AC plus CB squared. Okay, this is quadratic, so it's going to be AC plus 2 times AC times CB plus CB squared. So this is easy. But what do we know, guys? We know that in this triangle, Pythagoras tells us that AB squared plus AC squared plus CB squared. AB is equal to. So this is Pythagoras. Alright, so this implies that AC plus CB squared is equal to, now if we take AC squared and we add CB squared, what does that give us? It gives us AB squared plus 2 times AC times CB. Great. So this also implies that AC plus CB, I don't know why the square is all of a sudden inside. So guys, be vigilant. Obviously in the NBT, you're not really supposed to show the steps. What is AB? This is 10 squared plus 2 times AC times CB. This also implies that we've got AC plus CB all squared is equal to 100 plus 2 times AC times CB. We can make that equation 1 because we cannot move any further than this. Okay, so we know that, however, we were given that half of AC times CB. This is when we decide AC is the basal side of this triangle and this is the height. So we were told that this is equal to 11. So here we can then multiply by 2 throughout, such that we get AC times CB is equal to 22. Then we can express perhaps AC as 22 over CB. One could have chosen any other and make this one equation 2. Okay, again, if you noted, we're usually doing simultaneous equations. We can say here, if we put equation 2 into equation 1, what do we get? We get AC CB all squared is equal to 100 plus 2. Instead of AC we write 22 over, maybe let's not even put brackets, they will cause us problems, so just put a dot. Multiplication can be represented by that, times CB. Okay, perhaps this one is easy to try and show it as a fraction. Now we can see clearly that CB will take care of CB and the numerators multiply, the denominators multiply. So this implies that AC plus CB all squared is going to be equal to 100 plus 44. Right. So this means that AC plus CB is basically 144. And what can we do here? We can take the square root. And then we do the same here. Okay? So therefore, AC plus CB is going to be equal to 12 centimeters. Okay, now remember these are distances, so we're taking the positive answer. So remember, a perimeter is going to be AC plus CB plus AB. So we already have that sum, so we can say then perimeter of triangle ABC is going to be AB plus AC plus CB. Now we've got 10 here, plus these 2 gave us 12. So this is 22 centimeters. Okay, so therefore the answer in this question is, okay, essentially here we have a bit of a situation. Now we've got a situation here. So yeah, if we look here, it's option C. All right, guys, so this is essentially what can be done and should be done. All right, so when we are given a hint, we follow what we are given, because it means it's going to be much more difficult to do this without a calculator if we use any other means. So we have to take into account some of the suggested approaches. Sometimes we formulate our own approaches and we just keep moving. So I hope you guys enjoyed this video. So before I take too long, I'm going to cut it here, and I do hope and believe you have understood every single gymnastic we had to perform and that it makes sense for your learning experience. Otherwise, I'll see you some other time. Goodbye.